introduction to the platforms and a bit of a demo as well. So that should be really interesting. And then after that, we'll do a Q&A as well. So I'll get going. I don't want to spend too long on this because I know everybody's here for the demos and the intro. So next slide, please. Oh, there we go. Okay, so in the technical data group, we're focusing on, the foundations of the technical data that is needed in order to kind of de-risk the geothermal industry in the UK and what that should look like. Obviously, there's a lot of efforts that have gone into it already. There's a lot that exists and it's kind of all in different places. And obviously, entities like the BGS have done a really good job at bringing some of that together. And we want to take that a step further and work on some sort of standardization for the data, a lot like what we've seen in oil and gas and now CCS in the UK. Our focus areas are going to be on kind of collating all that data and bringing it together in one accessible place. So, you can get to the different data sources all from one source. And also going forward, what the data framework should look like in order to have some standardization, to bring that kind of bring that confidence to any investors in the UK geothermal industry, and as well as companies wanting to work here in the UK with geothermal. And I think in terms of the data frameworks, there's a lot we can do, and there's a lot we've been talking about because, like we said, there's a lot of things that already exist there today. So it's just creating that link to bring everything into one place, and also making sure that data is robust and what is needed to de-risk the geothermal projects. So this slide, you can read it for yourself, but obviously why it matters. We want to create those bankable projects, we want to de-risk the projects, we want it all to be evidence-led, based on data, increasing the confidence in everybody, getting the geothermal industry in the UK going and more scalable to what it is today. And then just one more slide. This is kind of where we've been going as a team. Obviously, everybody in the team is a volunteer, so we do this as well as our day jobs. But essentially, we're looking at a standardized data framework. We're looking at creating mind maps in order to help everybody be able to access and find all the data that is already available in the UK. So that's a lot to do with data mapping and all the standards. And that's kind of our phase one. That's our shorter term goals. And then, of course, we want to be able to build something that makes this more accessible to everybody. Basically with a front end that accesses to the different data points, and ultimately, building that kind of framework, that blueprint, if you will, to what data we need to be looking at going forward for the geothermal industry and what should be public, etc., and what kind of regulations would tie into that. So there's a lot of work being done on the back end, and there's a lot of work being done already. So we're just trying to bring that all together for the good of the geothermal industry in the UK. So with that being said, I will hand over to Alison, I think was going to go first, and let everybody check out the platform. Over to you, Alison. Thank you.
Thanks, Rebecca and Anne. Okay, so I'm just going to share my slides. So what I'm going to do today, I'm going to start off with a few slides giving a bit of background and context. And then I'm going to go into a sort of live demo where I do some things on the Map Explorer part of the geothermal platform. So this is a piece of work that was being funded by DESNZ and has been delivered and is being maintained by the British Geological Survey. So I'll go on to my next slide. So this diagram here illustrates the different pieces of how you get to geothermal at scale, in my opinion. And one of those pieces is data availability and accessibility. And as I'm sure you're all aware, countries that have a wider deployment of geothermal energy, they have open data platforms. And now we've got one because we've got the UK geothermal platform. So the motivation obviously is just to make data sets that existed more openly accessible. and available. So this is a geothermal energy information hub, and it was launched in August this year. It's both a website and some data access pages and a user guide, as well as the main thing that I'll show today is the Map Explorer part. It does incorporate, excuse me, it incorporates data sets from other organisations, mainly the government organisations like the Mining Remediation Authority, the North Sea Transition Authority, and the environmental agencies such as EA and SEPA, and also UCOGL, which is the UK Onshore Geophysical Library, which is a charitable organisation. The platform is open access, and the view parts of the platform that I'll show you, that they can be used, that information can be used for commercial purposes. So it's under an open government license. So all you have to do is acknowledge the source of the data, and it can be used for commercial purposes. So you can see on the image on the right, this is two of the important data sets that exist for underpinning geothermal in the UK. The kind of green to red map, that's the heat flow map of the UK. And behind that, we've got the legacy geothermal catalogue, which are like the data points. So there's over 11,000 data points on like temperature, thermal conductivity, and heat flow, and so on. So those are kind of accessible where those are, and so on, in the platform. And the platform is for a range of people. DESNZ were particularly interested in having information that could be fed into heat policy, heat networks, and so on. So I'm going to show you some summary layers which exist across the whole of GB, which give the potential for different geothermal technologies in the format that those policy people, decision makers, heat network people need, as well as local and regional government to look at those kind of regional assessments. And there's also that detailed data in there for kind of developers and researchers and so on. So just one slide looking at the types of data that's in there. So there's 90 layers of data altogether that's in this first version 1 of the geothermal platform. We've seen the heat flow map on the previous slide. This is an example of a legacy temperature map of the Cheshire Basin. There's a thermal properties information layer on things like thermal conductivity. And there's other kind of depth maps and theoretical geothermal potential maps from legacy data sets. And if you want to know more about each data set, then the little information button that we'll see when we go to the demo, that tells you, it's got the metadata, so it tells you where that's from and how that data can be used. There's also many layers on sort of environmental constraints, groundwater, coal mining, and so on, that a lot of those are brought in from other organisations. And at the same time as making the data sets open, BGS also released, there's over 60 legacy geothermal reports from the 1980s geothermal programme that previously were not publicly accessible in digital form. They were accessible if you came to the library, but they're now a lot more accessible on the publications viewer. Okay, so the summary layers, I'm just describe these and then I'm going to go into the demo. So there are summary layers that provide this pre-feasibility screening level information for policy and planning at local, regional government scale and so on. And really, they do two things. They make geothermal information for different technologies really visible to non-specialists, people who aren't geothermal experts, so that it can be considered as part of heat decarbonisation options. And as I mentioned, they feed into the fields that were defined, they feed into government policy, making models and so on, because they're the numbers that government actually needs to include geothermal as one of their technologies. So I'm going to show you in a minute 5 different layers. There's an overview layer that also includes cost estimation data from the ARUP study. And then there's 2 shallow geothermal layers, one open loop and one closed loop, and one deep geothermal layer. So it's like, you know, you're drilling down deeper, looking at the geothermal options underneath your piece of ground. Okay, so at this point, I am going to come out of the PowerPoint and go to the demo, and hope that it all works. So hopefully now you can see the website. So it's a very intuitive name, ukgeothermalplatform.org. So yeah, so this is a website that helps you navigate around the information and data and so on that's available. So I'll just kind of scroll down, but you can see the kind of thing that's in here. It gives you the kind of general information that I've just gone over in those introductory slides. And there are three parts to the platform. There's this overview page. Across the top here, there's then a data access page, which is where if you don't want to look at the data in a map form, a spatial form, you can search the data just on keywords and so on through the metadata. There's also the links to the reports that I mentioned here, these sort of 60 reports, and there's other links to other resources such as some of the standards and guidance, other screening tools and so on. So there's already a collection of things on this page. And then there are some how to use videos on another page which tell you how to use the Map Explorer. So I'm just going to pop over to the Map Explorer, which is the kind of main part where you can see the data. When you open it, you get a disclaimer to very much say that A, this is the first version of the geothermal platform, and B, when you look at this, it is pre-feasibility level information. You should always then go and engage a specialist when you've looked at this and if you're interested to take geothermal forward. So what I'm going to do on this platform, so I'm now in it live, I'll just give a bit of an overview so you can see all the different data layers down this slide. So I'm going to look in more detail at the geothermal summary potential layers that were on that kind of stack diagram. So I'll start with the overall layer. But just to show you, you know, these layers eventually, when the IT catches up, they cover the whole of GB. So you can do this for anywhere in GB, and they're a series of hexagons or hex cells. So the example I'm going to give you, I'm going to go into the north of Manchester and look at an area around Oldham where there happened to be lots of schools, and we had an inquiry about, you know, could we heat the school using geothermal in this area? And it's proved to be a very good example. So the overview layer, if we click on this hexagon, we can dock this descriptive text. There is quite a lot of text in here that gives you the kind of information. But essentially this overview layer drills down through all those different geothermal technologies that are included at the moment. So if you can read this, it's got closed loop, open loop, the different aquifers, deeper granite EGS systems, and whether we're in a coal mining reporting area or not. And then on the right-hand side, in this case, it's saying closed loop feasibility is high, open loop's medium. There are no Triassic aquifers or Permian aquifers judged to be of suitable temperatures at this location, but there are carboniferous aquifers, so we'll go and have a look at that in a moment, and we're within a coal mining reporting area. There's also, on the overview layer down here, there's cost information from the ARUP report, so summarised for the different technologies, the levelised cost, the CapEx and the OpEx. So we've now looked at that. We're really enthusiastic. Oh, let's look at closed loop because it's high feasibility. Okay, so we're going to zoom in and we're going to look at this location from the closed loop point of view, just to give you an indication of the types of fields that are in there. So this is the information for the closed loop. So we've got a description of the technology, the depth of the borehole and so on. And then it gives you how much heat you can get out of that borehole, how much you can get out of 50 boreholes, the annual estimated heat output. These are all numbers that are needed for that kind of government information that they need. It's got calculations on the supply side, like the other side of the heat pump. It gives you an indication of the temperature, of the feasibility and the confidence, how confident generally we are that that technology might work. And it gives you some information on the kind of range within this area of thermal outputs, because this is a summary of different geologies that vary within this area. And the range of that tells you something that there's a lot of different geologies, or if the range is very small, it's quite a simple geology. The geology is listed further down, and there's also a bit of information about how the outputs here relate to outputs across the rest of the country. The other thing to mention is that there is a very detailed methodology report. You can click on a link here, which will take you to that detailed methodology report that explains all the calculations and so on that have gone into making these output values. So we then might want to look at open loop summary layers. I'm not going to do that just now. The output fields are very similar to the closed loop ground source heat pump layer, but I'll just switch on the Carboniferous Aquifer unit so that we can look at that. I think it was down here. It was there. This has slightly different fields because the deep aquifer layers are more of a theoretical potential. The technical feasibility is lower because it's not a widely exploited or exploited at all geothermal target in the UK at the moment. But you get things again like the amount of energy output and the depth and temperature of that aquifer unit in that particular location. So that, yeah, that's the kind of thing you can get from that. And then finally, we noted that we're in a coal mining reporting area. So we've got the opportunity layers done by the Mining Remediation Authority in here. So these are the layers for Manchester. And it's a slightly different way of looking at the data because it's been done by Mining Remediation Authority. But here we've got a classification in that area we're looking at where it's a good area for mine water heat opportunities. Obviously, there's not a huge amount of information there, but if you click on the information button, that takes you to the data.gov website where you can find out an awful lot more. There's the descriptive report and the detail of all those maps. So all those things are kind of linked in and back to this. So just to kind of finalize on the Map Explorer, and then I've got one summary slide. You can see down here, you've got all your legacy geothermal regional maps for different hot sedimentary aquifers and a range of geothermal information. You can change things like the transparency on here. You can change the order. So you can do, more bespoke things with it to look at a particular site. And obviously you can zoom right out and look at more regional impacts. Just in summary, hopefully you can see that the UK geothermal platform is a big step forward in getting the geothermal data that previously was in reports, it was in kind of cupboards and so on, out there, available and accessible. There's information there if you're a specialist. There's information there if you're more like a planner or a policy maker in the summary layers. And it gives government more visibility on geothermal, which in turn should help the, that progress. We're very much aiming that this is a first version and there'll be more versions that incorporate user feedback, more layers and different geothermal technologies. And one of the key things that we're really keen to do is gather in new data and information from other people. And so it is really that hub of geothermal information, and also use that to really improve the evidence base from these legacy models to kind of newer, more updated models. So I shall stop there and thank you very much.
All right. Thank you, Alison. That was great. I really like it. I was just checking out the geothermal potential at my house, actually, out of curiosity. It's really easy to use. Well, we'll go ahead with you, Steph, if you're ready to go.
Thank you very much, everyone. So let me just share my screen. I'm also going to attempt to swap between slides and the website, so fingers crossed. So for those of you who don't know me, my name is Steph Parker. I'm a senior advisor at Energy Systems Catapult. Energy Systems Catapult is an independent, not-for-profit, part funded by government, so not quite the same as BGS, but similar. And we're here to help the UK transition to net zero in line with the government's targets. So our whole role is around innovation, developing markets, and sort of accelerating the transition. I'm going to talk to you today about a tool that we have built hand in hand with Alison's team over at BGS, which stemmed from our work in the public sector. So since about 2018, we've been doing a lot of work with DESNZ to support the public sector to decarbonise. And obviously a lot of the challenge there is heat decarbonisation and how you go about that. So I'm going to talk you through the tool, how it's made up, the kind of component parts, and then show you quickly the website. So fingers crossed, this will all work. Right, so a little bit more about the background of the tool. So the original version of this was developed between BGS, NHS England and the Catapult. NHS England, as you can imagine, have lots of big campus-style sites, NHS trusts with high heat demand, 24/7 operations. So they're really ideal for ground source heat pumps. And NHS England wanted a way to help sites think about how geothermal could be used on their sites and make it easier for them to do that. So the kind of audience for this tool is really site managers, estates, facilities, sustainability people within the public sector. It's a really fun tool to use. It's really easy, basic building data that an estates or facilities person would have, and then it does some clever mashing together with the BGS data. It is an initial screening tool, so same as Alison was talking about for the platform, this doesn't replace needing a specialist to come out to the site to look at your actual potential and do that feasibility study. But what it does do is help trusts understand the sort of potential on their site. And as I show you the tool, you'll see what I mean with the results pages. So just a bit about the tool architecture. It's hosted on Amazon Web Services. It's free to access. There's a web page that you use to interact with the tool. And then there's essentially two databases behind the tool. One is the geothermal layer from BGS, and the other is a kind of building data layer from ESC, built up from our knowledge of the public sector. And again, when I go through the tool, essentially you can put energy data into the tool, but if you don't have that, Energy Systems Catapult has benchmarks for different public sector building types that it can still run the tool with. So trying to, again, make it as easy as possible for use. And then essentially has a computation module that works out essentially how much of your heat demand ground source could provide. So again, it'll become clearer when I show you the tool. I'm not going to talk through this slide. It's for the people who are more interested in the techie stuff, but this gives you a bit more information about the inputs that you need to provide and the assumptions and calculations. The original version, as I said, was built with NHS England, so only covered NHS sites. But then towards the end of last financial year, so early this year, DESNZ funded the expansion of the tool and some improvements. So it now works for all public sector building types, and that actually includes offices. So technically it works for any office, because public sector offices is no different from a commercial office. But we also made some improvements to the results pages, because essentially the question that public sector sites will be asking is ground source better for me than air source? So we were able to make some improvements to add in that comparison into the results table. I'll obviously put the link to the tool in the chat, but there is a little QR code there that if you want to get cracking straight away. This again is sort of a first version of the tool. We would love to continue to improve and expand the tool. So I've just got a few of the things that we would love to do on this slide. The tool only at the moment works for England, and that's because the original tool was funded by NHS England to only cover England, if that is not too obvious. Like I say, there's loads of things we could do to improve the tool. A big one would be to be able to add in half-hourly energy profiles rather than sort of annual and peak demand. Think about cooling, which would improve the business case in a lot of cases for ground source, and enable you to do bulk upload of site information. So at the moment, the tool works on a site-by-site basis. So if you're in a sort of portfolio situation, at the moment, you'd have to enter each site separately and sort of compare the results. So we'd love to build something that was able to do that more easily. So I'm going to use a little demo that's preloaded into the tool. I'll be super quick just to give you a feel for it, but it is based on an actual MOD site. So let's see if I can swap over to the tool. There we go, that worked quite well. So this is the landing page for the tool. Just to notice a few things across the top. So there is a much better video demo than I'm going to do in the 5-10 minutes I've got now. So do watch that video. That talks you through all the inputs, all the outputs, and gives a really clear explanation of the tool. There's a quick start guide. So that is really the guide for using the tool. And then the tool guidance is much more about what's going on under the hood. So again, for people who are more interested in the technical side of it. As you'll see, you come to this nice landing page, click Get Started. You can recall the results from previous entries to the tool. So when you go through it for the first time, it will give you a passcode, and then you can re-enter that. We did this to avoid having logins, because logins make things complicated. So this is a kind of easy way for you to recall your results. So I'm sort of preloading this MOD site in with this, so you won't have to painfully watch me type in all the data as we go through the demo. So the first page you'll get to is kind of the site and location information. So you can choose your site name, and the tool uses what 3 words to pick up your location. So, you know, if you're looking at this MOD site, we picked some fields that are sort of just out, well, within the boundaries of the site, but just close to the buildings. You choose the land available for boreholes. So this tool at the moment only does a calculation for closed loop boreholes, but it does provide you information about open systems as well. And you can choose between 100 and 200 meters for your borehole depth. Again, another improvement, we'd like to expand that slightly deeper, 300 at least. Because the tool's a screening tool, at the moment it assumes the space you put in for boreholes is a square space. Again, another improvement we could make where you could sort of draw on a map and it would work out how many boreholes you could fit in a space. It can't do that at the moment. It just assumes that it's a square. But again, that, you know, could affect your results depending on the actual shape of the ground that you have. So then it goes through to the building data page. I think you can add up to 10 buildings per site. And I'm just obviously have added one, and we'll just show you for one. So essentially the basic information about the building. So we've gone for a barracks. Building data building is important because the tool's doing calculations about heat. So it wants to know when it was built in relation to building regulations and how efficient the building's likely to be. You then get your drop downs for the different public sector building types and the options within here. So that covers all the different public sector types. Then adding in some basic information about your internal floor space, building perimeter, you can calculate that off Google Maps if you don't know, and floors and heights between floors. Like I say, we have tested this with facilities, estates people. This is the kind of data that they can lay their hands on usually pretty quickly, so it's not too onerous to fill in. Information about your current heating system. We're presuming it's fossil fuel and that's what you want to move away from. And then this is optional for your peak and annual energy demand. If you put in your actual demand, it will be more accurate. If you don't put it in, it'll use the benchmarks in the tool. So it doesn't stop you using the tool if you don't have that. A little option around whether your building is essentially a 9-to-5 building or a full 24/7 building. And then you can add some options around the current construction and whether you're planning any upgrades. So we know that often these projects to replace heat are done alongside fabric upgrades. So obviously if you do some fabric upgrades, that will affect your heat demand and therefore the sort of size of heat pump and how many boreholes you need. So once you've confirmed, you click Get Results. It's that easy. So it shouldn't take too long. And essentially you get this top line result where it's looked at your heating demand for the buildings you put in, it looked at the ground you've got available, it looks at the BGS data, and it tells you how much of your heat you can get out of the ground. Oh, I just got a little round of applause there for the tool. Yeah, great. As you can see a PDF. You can print a PDF of the results. We were hoping that people would be able to use that to cut out tables and charts for business cases, you know, for engaging with seniors. I'm not going to go through the results step by step because it will just take too long, but I'll just sort of show you around the outputs page. Here's the code that I mentioned, so you can recall your results. You don't have to re-enter them each time. You get a little recap of the site details and the building. So if you get something really funky out of the results, then you can just quickly check, oh, if I put something mad in my inputs. And then you get these different output layers. So you get information about the site geology, any additional information. So here it's talking about no coal mining, open loop is favourable, as well as obviously the tool's looking at closed loop. Then you get the sort of improvements we've made where it's showing you the demand and how much of that demand can be met. And again, you can see there's two bars. So if you put in detail about fabric upgrades, it'll show you the difference that's made. And then importantly, it's got stuff around costs and carbon. So what are the costs looking like with your current heating system, air source and ground source? And it will do top-ups as well. So the options it'll do is it'll compare ground source against your current heating system, air source against your current heating system, and then it'll top up a ground source with an air source and with your or with your current heating system to kind of give you those different options. And then there is a little sort of further guidance and next steps, which we should probably add a bit more information on there because it just points you at the use guide. But yeah, future development to point people in the right direction as to where to go next. So yes, hopefully a very quick demo. Like I say, if you're really interested in using the tool, the thing to do is watch the video because Alice, our modeler, who worked with really closely with BGS and built this, has gone through it in much more detail. I suppose what I would say in summary is we think there's lots of potential for this tool. Only covers public sector at the moment. No reason why it couldn't cover commercial or industrial, housing. Obviously, closed loop boreholes are probably not suitable for single dwellings because drilling a big hole in your back garden is very expensive, but could be used in other domestic settings. So new towns that are being built, retrofit of large blocks. So there's probably domestic application as well. So yeah, I think this is a great piece of work. We're continuing to seek funding to improve it. And yeah, very happy to take any feedback. I will pop the link to the tool and our sort of generic email address in the chat. So if people want to get in touch, they can. So thank you. I will stop sharing and happy to take any questions.
All right, that was great. Yeah, and it's really straightforward, really easy to use. I think both tools are fantastic, especially for first versions. Like you keep saying first version, but it looks way more advanced than first versions. We do have a couple of questions in the chat, so I can start off with those questions and then see if anybody else wants to come off mic to have some more questions. So I think the first one was for Alison. So it says, will there be water geochemistry layer where geothermalmetry studies can be performed?
So I've got a number of answers. There are links already in there to the water monitoring data that is done for groundwater by the Environment Agency and SEPA. So it'll take you across to their platform. Now that's not for kind of deep geothermal purposes, but it is their monitoring data, their chemistry data, the sort of baseline data that they have. So you can get to that information from there. In terms of deep groundwater geochemistry from boreholes and so on, the challenge at the moment is that there is no unified database that exists currently. It's all held in different places. And so the 90 layers that are in there are things that for a first version we could easily get through an approval system that BGS has, and get out there and published. And there's a lot of data sets that people have requested, of which water geochemistry is one, that we would love to put out there, but it would take weeks to months of work to actually get a kind of background data set to start with. And so we are looking out for those opportunities where we can get funding for that kind of work all the time. But yeah, it'll one thing we really recommend or ask you for is your feedback about, if you are interested in a particular layer, then let us know, because obviously the more people that request that layer, that gives us the evidence to make a business case to say, look, people are really needing that layer. So, you know, if water chemistry for geothermometry studies is really important, then that would be one. It's certainly one that we had stakeholder workshops and people did ask for that then. Yeah. Thank you.
And there was one other question about, will seismic data be added in the future?
Yeah, so the seismic lines, the onshore legacy seismic lines, they're in there at the moment, under one of the layers. And what that does is it shows you the location. You can click on it. It takes you over to the UCOGL website. And on the UCOGL website, you can both, there's like a little image viewer that you can do. And you can get a lot more information about each seismic line, and if you want to use those, you can kind of get that data through the UCOGL process. So it does integrate that where the seismic lines are in there, so you can see the position of them when you're looking at your studies.
Okay, thank you. And a question for Steph. Can the screening tool be used to acquire permit for drilling the boreholes? i.e., is the tool certified within other stakeholders to ease the process?
So not at the moment, I think, is the answer to that. So this is still a screening tool. So you would have to then get someone on site, you know, actually look at how many boreholes you need, what depth, where you're going to put them, probably drill a test borehole before you proceed. I'm not familiar, Alison, you might be able to help me out about what point you need a permit. So I'm sympathetic to the point about having a process where everyone follows the same process, then it's all linked. But I don't think we've got as far as thinking about permits in terms of improvements. So yeah, I don't know if Alison, you've got anything else to add.
I mean, I would echo what you said, that very much all of these tools are really pre-feasibility screening tools. So you would really have to do more work in looking at the detail of the legacy data that's around there to assess if that site is suitable before you get to the stage of thinking, okay, now I'm going to drill, do I need a permit? In the tool that Steph described, there is more constraints information. So it does give you more information on things you might need to think about if you were thinking of drilling a borehole. So yeah, that could be quite helpful in you thinking that through.
And one last question in the chat is there data here for deep geothermal electricity production?
Unfortunately, no, not in the geothermal platform. For I guess two reasons. One is that the focus for this funding this piece of research for DESNZ was on the heat side. Not that they're not interested in the power side, and there was interest from that, and there's the cost estimation work from Arup includes power production. But the underpinning data for deep electricity production and how you would classify that is still, there's different techniques, and the data and way that you would estimate that is quite complicated. And again, like I said before, it wasn't something that we had from previous studies that's been peer reviewed and so on. So it doesn't exist at the moment, but that's the kind of thing looking forward, you know, those different technologies, we would like to look either ourselves or other organizations that have those kind of data sets to include those to make it more widely applicable.
Yeah, thank you. And then another question did pop up about either of the tools plans to be integrated within the heat network zoning from DESNZ. Would be really useful to work out how many of the prospective zones are in areas of enhanced geothermal potential.
So
I think we'll probably both have a go at this question.
Yeah, go on, Steph, you go first.
So this is really exciting, I think. So the ESC tool that we've built is built in Python. So separate to what we have done with this tool, we have also done some ArcGIS mapping of the public sector and where all the public sector buildings are in at least England, if not England, Wales, and Scotland. So we've got this mapping. The mapping brings in things like EPC data, deck data. So it has fuel, the fuel that the buildings are using. We have benchmark energy consumption. So theoretically, we could run the logic from the BGS tool across all of the public sector. We just don't have the funding to do that, or we haven't sat down and thought about it in enough detail. But absolutely, you could run it in the heat network zones. So it would be a great thing to do. We just haven't wrapped our heads around it yet. But both of the things that we have are written in Python and shouldn't be that difficult to mash together, way beyond my capabilities, but we have people in the Catapult that do this sort of things. So yeah, I mean, it would be great to see the anchor load potential for big public sector sites within those heat network zones. I would suggest the one improvement that you would want to make to the tool as a priority there is being able to put in the actual area you've got for boreholes. So like drawing it on a map or something like that, because that might make quite a big difference to the results. But yes, we should definitely keep talking about that. So yeah, follow up. Do email me if you want to chat more about this.
And from my side, the information that's in the platform, the background data has gone to DESNZ, because that was part of the reason they funded the work, very much with the intention that it feeds into the national zoning model, which underpins those heat network zones. I'm not party to the results of any work or what's happened to that, but that was absolutely very much the intention of why they wanted those different geothermal options and heat outputs at the different 236,000 locations across GB. So fingers crossed, and we'll wait and see.
All right. So I think we're at about time. There is one more question about the funding that the projects have received. I don't know if that's public information or not, or something you would share. I'm sure some of it is public, but I don't know if there's any comments on that. Otherwise,
I'm happy. Alison, I presume our award for the our tool was published, so I'm probably all right to say. Yeah. So the BGS ESC tool cost around 250k to put together. And DESNZ added a little bit more funding to expand it from just NHS sites to all public sector sites, but that's actually quite a straightforward amend, because you're not messing with any of the calculations of the tool. You're just adding more data to a database and making some slight tweaks to the front end of the tool, so there's drop downs. So yeah, about 250k to put that tool together, but BGS for that tool had to create the screening layer, which wasn't available before. That's right, isn't it, Alison? So that was a lot of work to create that 1 kilometer hex screening layer for the tool. So that was a big chunk of the costs.
And yeah, for the geothermal platform, again, that's because it's all public, so you can find that information if you know where to look. So yeah, again, it was £200,000 was the cost for the UK geothermal platform. BGS kind of supplemented that in a way by making a lot of the data more available than it had been previously. So a little bit of BGS's own funding for those aspects for a lot of the legacy data. But yeah, those are the kind of numbers we're talking about.
All right, thank you. Well, I think that's all the questions, and I think we're out of time. Thank you both for the demos. I don't know, Anne, if you have some closing words you'd like to say.
Well, thank you all. Thank you, Rebecca. Thank you, Alison. Thank you, Steph. That's great to see those demos and to see the information that's already available. Brilliant. Thank you so many to everybody who joined us today. And also, Rebecca, I believe this is the first of 2 webinars. In the new year, we're going to look at a couple more platforms that are available.
Oh, yes. Yeah.
Thanks. So I'll be sharing the recording. Thank you very much for joining us today, and thanks for the presentations. Thank you. Bye.
Thank you.
Thank you.